Okay, so this is part 2 of the Unit 4 review. So I was going to walk through letter E here. So for letter E, you're going to want to use U substitution, but what I did first is rewrite it. So I just rewrote it. I didn't take the integral, so notice the integrand's still there. I wrote it as 1 over this, and then I just kind of moved that out to the side. The reason I did that, I think it's going to make it easier to see when I get my U and my du that it'll fit in there. So I'm going to say that U equals, well, I say U is whatever the parentheses are. So I've got 4x cubed plus 5 is my u, which means that my du, the derivative of that, is going to be 12x squared dx. Now, that's not exactly what I have going on over here, so I want to multiply that by 1/3. 1/3 du equals, if I divide that by 3, I get 4x squared dx. That's exactly what I want. So now I'm able to integrate, okay? So again, when I integrate, I like to pull the 1/3 out front. So I would say this is now going to be equivalent to 1/3, the integration of 1 over u to the 4th du. Now I'm going to take this u to the 4th. I'm going to bring it up to the numerator. Okay, so it would be a negative 4. And then from there, I'm going to add 1 to the exponent and divide. So let's see, if I brought that up, it'd be to the negative 4. So again, I'm going to add 1 to the exponent, so that would make it a negative 3, divided by this, and don't forget your plus c. Okay, now I'm going to scooch way over here because I'm running out of room. Okay, so that would be equivalent to 1/3. And then, oh, I still have this, so I could actually make that a negative 9. Right, because this 3 and this 3 are going to multiply to be a negative 9. So let's do that. Let's say negative 1/9. Okay, and then I'm going to take this u, bring it back into the denominator, so it would be a positive u to the 3rd, okay, plus c. And then for my last step, I could go back and substitute that back in. So I've got negative 1 over, okay, 9. My u value was 4x cubed plus 5, close parentheses, and that's going to be raised to the 3rd power plus c. Perfect. Okay, and then I have the other answers for those two down there, so you could pause and take a look at those and check your work as you go. Okay, so in this section we are finding definite integrals. You know that they're definite integrals because you have numbers here on your integrand. So we should not end up with any x's in our answers. We're going to end up with just a number. These, if they were on a calculator section, that would be good news because you can use your calculator to check all your answers here. You could just do Math 9 to check all of your answers. But this would appear on a non-calculator section because that would make it a little harder. So here we're taking sine of this. This is going to have to be a u substitution one, so it'll give us a little more practice with u sub. So again, I let my u be whatever's in parentheses, so my u here is going to be 4x. So that means that du equals 4 dx. And that is not exactly what I want. I want dx to be by itself, so that means I'm going to have to take a 1/4 out. So now this matches what I have there. So also, I need to adjust my limits. So my new limits, okay, so my new limits, I'm going to figure that out by taking the old ones and plugging it into u. So I was at 0. Now, when I plug 0 into u, 0 times 4 is 0, so that stays the same. But when I plug in pi over 4, okay, if I plug in pi over 4 and plug it in, pi over 4 times 4 is pi. Okay. So now I'm going to kind of use all that to rewrite this. So now this is going to be mathematically equivalent to 1/4 from here. So 1/4 of the integral from 0 to pi this time, okay, of sine of u du. Okay, so using our trig chart, where you want to go up from sine to take the integral, well, sine's already at the top of the chart. So it's going to be negative cos. So I'm going to float my negative out front because that is a constant. So you have negative 1/4. Okay. Cosine u. And that's going to be evaluated at 0 and pi now. Okay, so now you're just going to plug in there. Okay, so that's going to be cosine of pi. So cosine of pi is going to be -1 minus, now I plug in 0, cosine of 0 is 1. So I've got that. Well, let's see, that's 1/4 times a -2. I'm sorry, -1/4 times -2. So that's going to give me a positive, and that'll be 2/4 is 1/2 is my final answer there. Okay. So next we have this one. You do not need U substitution. This is straight just using your trig chart there. So from sine, we're going to be negative cosine of x. Okay. And then negative cos will be negative sine. So we go 2 minus 2 sine x. And again, we're evaluating this at 0 to pi. No need to adjust the limits because it's not U sub. And so from here, it is straight unit circles. Let's see if I plug in a pi. So you have the cosine of pi is -1, but it's negated. So we're going to have 1. Okay, so we get 1. Now I plug in pi over here. So the sine of pi. Well, sine of pi is 0, so it'll be minus 0. So yeah, plus 0 minus 0 doesn't matter there. And it's minus, now I have to plug in 0. Cosine of 0 is 1, but it's negative. So that's a -1 there. Plug in a 0 there. Let's see, the sine of 0 is 0. Right, so we get this. That'll be minus 0 there. And from there, it's just kind of cleaning it up. This gives me 1. That's minus a -1 turns to a plus. So that should give me a final answer of 2. And again, you could check these on the calculator via Math 9. Oh, and let me scooch over so you could see that other one there if you're kind of checking your work on the others. Okay. So this one's going to be another U substitution. Okay, so I'm going to say that U, for this one, I like to make U whatever's in the parentheses there. So that means that du is going to be 1 dx. Okay, that actually works out perfect because that's what I have left. So I do not need to, make any adjustments to the du. I could just go ahead. I do need to adjust my limits though. So when you adjust your limits, 0, let's see, if I plug in 0 there, I get a -2. And when I plug in 1, okay, if I plug in 1 minus 2, gives me a -1. So when I go to rewrite this, okay, it's going to be the integration from -1, oops, sorry, this is a -2 to -1 there. And it's going to be, well, 1 over u to the third. Well, instead of writing it 1 over u to the third, I'm just going to write it as u to the -3 du. Save a step there. From there, you're just adding 1 to the exponent, dividing by that number. So I'm going to add 1 to the exponent. That'll make it a -2 divided by -2. And I'm evaluating this at -2 and -1. And from there, you could probably rearrange this. I might want to rewrite it. So this is mathematically equivalent, right? So you could have that, -1/2 kind of out front and pop that u into the denominator to make it a positive squared. So you've got -1/2, and then times, you could have it as 1 over u squared evaluated at those two. Oh, I'm running out of room there, sorry. Okay, so when you plug in, I'm going to keep that the -1/2 out front. Alright, when I plug in -1 there, -1 squared, well, that's 1, so I get 1 over 1 is 1, minus, when I plug in a -2 squared is 4, so minus 1/4. Close that parentheses up. So kind of change this into fourths. That's 4/4. So I have 4/4 minus 1/4 is 3/4. So really what I'm doing is -1/2 times 3/4. So my final answer there is going to be -3/8 is my final answer for that one. Sorry, my arm was in the way there. So you've got that. And I'll scooch it over a little so you can see the work for the others. Okay. And last one here. Okay, so we've got this. I would probably take a minute and rewrite this one and then reduce, okay? So if you wanted to rewrite it as t to the 6th over 4 minus t squared over 4, then you can reduce it. So I'd say that this is mathematically equivalent, okay? Remember to subtract your exponents there, so that's going to be equivalent to t squared, okay, minus t to the negative 2, or you could then rewrite it as, you know, that in the denominator. Doesn't really matter. Oh, and that's, sorry, going to be dt. Okay. So now once you get it to there, you can just integrate. So add 1 to the exponent, divide by that number. Add 1 to the exponent, divide by that number. So watch your negatives there. And I'm evaluating this at from 1 to 2. Okay, so from here, you're probably going to want to clean it up. Like I would rewrite this as a plus 1 over t. Okay, that would probably make it a little bit easier to understand. So I'm going to keep this. That'll be plus 1 over t. Still evaluating that from 1 to 2. And then from there, you're just plugging in. Okay, so when you plug in a 2, that's going to be 8/3 plus a half minus, okay, whatever you get when you plug in 1, so you get 1/3 and then plus 1. So, you got to change all those to 6ths, I believe, to get a common denominator there of a 6th. Get a common denominator here. You could get it of a 3rd, but then you're eventually going to have to change it to 6 to put that in there. Once you clean up that math, so you'd probably end up with, like, if you want to see one more line of work, 19/6 minus 8/6, and that's going to give you a final answer of 11/6 as your final answer there. Okay, so go ahead and check your work on those before we get into the last page. Okay, so this is the last page here, and let's talk about average values. So remember, the formula for average value, it's 1 over b minus a, the integral from a to b of f of x dx. So in that first one, that's what I did there, and you're just kind of plugging in. Just watch your fractions. You can get tangled up in theirs, but you get an answer. If you are allowed to use your calculator, you would kind of do the setup very similarly. Now remember, on calculator problems, I highly recommend that you kind of show what you're doing. So I would say 1 over, this is your a and your b, so it's b minus a, the integration from a to b of your f of x is ln of this. Watch your parentheses, okay? So you would end up doing, what is that, 1/4, right? So this is 1/4. And then via math 9, you would get a number and just multiply it by that. So you'd still use your calculator for this part, but by showing this work, you would ensure yourself some partial credit. And if you type that in, you should get 3.035 when you go ahead and take account that fourth as well. Okay. So the next section here, it's all about just your properties. Remember, the area over no space is 0. Another property says you could break things into parts. That's what's going on here. Another property says that if you want to flip these, you have to make it a negative. And you can always take a constant out front and then multiply at the end. So that's what's happening there. Okay, find the derivative of each function. These are the ones that are a little bit tricky because it's using your second fundamental theorem of calculus. It says find the derivative, but you're like, oh, there's an integral. So you want it to be of the form a number to x. If it's of the form a number to x, okay, those are the easy ones because you can literally just replace. The other problems you're going to have is if it is x to a number, then you can apply the same property you did up here, just flip and negate. So you could do that. Now, if it is a number to a function of x, this is where you're going to have to replace this. You can replace your t's with this, but then you also need to multiply by the derivative. Okay, you also need to multiply by the derivative. Then, something like this one, you're going to have to apply that property where you can flip, negate, and go ahead with your functions. So I'm going to fill those in, and then you can look at the answers. Okay, so I went ahead and worked through those because I'm short on time here. So that's just applying the rules, and you could compare your answers to those. Have a great day.